Good afternoon. My name is Brittany, and I will be your conference operator today. At this time, I would like to welcome everyone to the Materialized Views Basic Architecture and Internal Working conference call. All lines have been placed on mute to prevent any background noise. After the speaker's remarks, there will be a question and answer session. If you would like to ask a question during this time, simply press star and the number 1 on your telephone keypad. If you would like to withdraw your question, press the pound key. Thank you. Mr. Jens Vaught, you may begin your conference.
Okay, thank you, and hello to everyone. Thanks for joining us today. My name is Jens Vogt, and I would like to welcome you to today's Advisor webcast, Materialized Views, Basics, Architecture, and Internal Working. Our speaker today is Shibata Da, Senior Software Engineer. We expect today's webcast to last approximately 60 minutes, including a brief Q&A session. All attendees can ask questions via the Q&A panel located on the right side of your screen. Phone attendees can also ask questions directly during Q&A session managed by an operator after our presentation. Unanswered threads we will transfer to community, and a product specialist will reply in the next few days. In addition, you can post questions to community at any time. Recording of this session and material becomes available within 48 hours, and I will provide download instructions after Q&A at the end of our webcast. Our safe harbor statement. Please remember, this Advisor webcast is intended for information purposes only. Any feature or functionality described for Oracle's products remains at sole discretion of Oracle. Now, let's get started with our presentation. Shibata, if you're ready, I will turn over webcast to you, and you can begin.
Yeah, sure, Jens. Hello, everybody. After completing this session, you should be able to understand the internal architecture of the materialized view and usage of materialized views. Different types of materialized views, various refresh methods that are available for materialized view, and the most appropriate one suited for the materialized view to meet the business requirement. Creation of the materialized view with pre-built table option. To achieve the objectives, we have the agenda covering basics of materialized view, architecture and usage of materialized views, advantages and disadvantages of using materialized views, various types of available materialized views, refresh methods, and complex materialized view, creation of the materialized view with pre-built table option, analyzing the materialized view, fast refresh. Overview. A materialized view is a database object that stores the result of a query at a single point in time. The mandatory syntax to create the materialized view is create materialized view name as select column names, column 1, column 2, blah, blah, blah from table names. Rest of the clauses are not mandatory. The usage depends upon the business requirement. If we don't specify rest of the clauses like build, immediate deferred, refresh fast, complete or force, on commit, demand, enable, disable query rewrite, on pre-built table option, these clauses will be automatically taken care of and the default value will be assigned. Materialized view is same as create table as select statement, but create table as select statement performs only a single copy of data. However, we have refresh mechanism to sync the materialized view with the master objects that we will see later in this section. As we can refresh the materialized views, so we can say that materialized views are dynamic and flexible in nature, unlike a normal view or a create table as select statement. Materialized views can be local or remote. I will be covering this in the forthcoming slides. Terminology that is used in materialized view environment is master objects. Master objects of the materialized view are the objects referred in the underlying select query of the materialized view. Master objects can be tables, views, or materialized views itself. Moving back to the previous slide, the creation script of the materialized view, we can see tab 1 in the underlying select query of the materialized view. That's as select column 1, column 2 from tab 1. Here tab 1 is the master object as it is referenced in the from clause of the materialized view underlying select query. Moving back to the previous slide. Master site. Master site is the site where the master objects of the materialized view reside. Materialized view site. It is the site where materialized view is actually created. It could be local or remote. Base tables. When a materialized view is created under the covers, there are two objects that get created with the materialized view. One is a table, and on top of the table is the materialized view itself. The table which gets created with the creation of the materialized view is referred as base table. And the base table name and the materialized view name is same. And if we check the DBA objects, the base table will have a different ID than the materialized view. Database links. Database links are used in distributed environments for data transfer. In case of materialized views also, if the master site and the materialized view site are present at different geographical locations, we can transfer the data using database links. In addition to these, I would like to specify here the materialized view log itself because that will lead to better understanding in the forthcoming slides. Materialized view log is a table that has to be created manually by the user in case we want to fast refresh the materialized view. I will be covering this in detail in the forthcoming slides, but just keep in mind that this is a structure which user needs to manually create at the master site. Local materialized views. Local materialized views have the master tables or master objects present in the same site as that of the materialized view site. Say in this particular slide we have Boston, and at Boston we have master table. So Boston is called as the master site since the master table is present at Boston. We have created a materialized view at Boston itself. So Boston acts as a master site as materialized view site as well. So Boston is the master site as well as the materialized view site. Remote materialized views. In figure we have Boston and Chicago as two sites. The master objects are present at Boston and the materialized view has been created at Chicago. So this is a remote materialized view since the master objects are present at a different geographical location and data is fetched between the two sites using a database link. Features or capabilities of materialized views. Materialized views can be used for replication and in data warehousing environments as well. Since materialized view can store result of a query, so it's used to improve query performance for expensive queries. Say a query has expensive joins and aggregations. If this query is run directly over the master objects, it can be very expensive. However, if the result set is already present in the materialized view, the query result can be fetched directly from the materialized view instead of running the query on master object. So we may say that materialized views are used to cache expensive queries in data warehousing environments, and in distributed environments, materialized views can be used for replication purpose. Since materialized views are physical in nature, so these are stored as table segments. Select statement is used to select data from the materialized view. No additional coding needs to be done to select from the materialized view. We don't need a dedicated connection for materialized views. A network connection is only required when we refresh the materialized views. Otherwise, we can do without the dedicated network connection as well. Data synchronization is either done manually or automatically at scheduled intervals. This I will be covering in the later slides in detail. Advantages and disadvantages of using materialized views. As we have discussed in the previous slide as well, that materialized views are used for expensive joins and aggregations. So these are useful for summarizing, pre-computing data and replication purpose in distributed environments. They provide fast access for expensive queries and complex joins. End user just has to run the desired query. If optimizer determines that the results are present in the materialized view, data will be fetched directly from the materialized view, thus avoiding the overhead of running the query on master objects. If a materialized view is dropped, query will not be impacted. Query will be run on the master objects without any impact. There are always maintenance costs associated with the materialized view, because in order to keep the materialized view in sync with the master objects, we need to run the refresh mechanism, and cost is always associated with the refresh mechanism. Since materialized views are physical in nature, so data is stored physically, leading to storage costs. This brings us to the first demonstration section. In this demonstration section, I will show you the difference between a normal table and the materialized view. So here we will be covering a test user, that is test 221. We will grant the necessary privileges, the basic privileges to test 221, as well as the privileges that are required and that are specific to do materialized view operations. So I have granted the basic create, connect session and resource to test 221. Now I will be granting the privileges to do the materialized view related operations. Here we go. So we have granted the necessary privileges, that is grant create any materialized view to test 221, as well as I will grant the drop materialized view privilege to test 221 as well, so as to clean up the setup at the end of demo 1. Now we are connecting as test 221, and we will create a master object, that is master 1 with P number and P name. Now we will alter the master table master 1 to have a primary key and insert a record into this as 1 and P1 and commit this record. After the record is committed, I'm going to create a test 1 table as select star from the master table, that is master 1. This is a simple table. So the table is created, and let us select from this particular table to see the records present in this. So the records in the table are P number and P name as 1 and P1. Now we will create a materialized view with the same underlying select query that we have used for test 1. Here we go. The materialized view is created. Now let us see what information is contained in the materialized view. It is same as in the table test 1. Now we will insert one more record into the master table, that is master 1 as 3 and P3, and commit this particular record and select again from the test 1. Now we can see the record, newly inserted record, that is 3 and P3, is not present in the test 1 table. Now we will see if this record is present in the materialized view. we can see the record is also not present in the materialized view because we have a refresh mechanism to refresh the materialized view and keep it in sync with the master object. So once we perform the refresh of the materialized view, we can see the latest record will get reflected in the materialized view. So this is the refresh procedure dbms_mview.refresh to refresh the materialized view. Now it has been completed, so let us see if the record is present in the materialized view. Yes, it's present in the materialized view. The recently inserted data, that is 3 and P3, is present in the materialized view. So here comes the difference between the table and a simple materialized view. For a materialized view, we have the refresh mechanism to sync the data with the master. So in other words, we can say it's more flexible and dynamic than the normal table. This brings us to end of the first demonstration. Now let's go back to the main slides. Refresh materialized views. We can refresh the materialized views either as complete refresh, fast refresh, or force refresh. I shall be covering each refresh type in detail in the forthcoming slides. Complete refresh. The figure demonstrates the setup for the complete refresh. We have two sites, Boston and Chicago. The master table tab 1 is present at Boston and the materialized view has been created as Chicago. The creation script of the materialized view is in the coded box, and we have used a database link to transfer the data between the two sites. So when the materialized view is created, initially it will have the same data as that of the master object. But if the master object, in this particular case, tab 1, is updated or deleted or a record is inserted into the master table, the materialized view will not be in sync with the master table. In order to sync the materialized view, let us perform the complete refresh of the materialized view and see what happens under the covers. So when we perform the complete refresh of the materialized view, the underlying query is run at Boston. At Chicago, the already existing data in the materialized view is removed by deleting or truncating the materialized view base table. Once this is done, the materialized view at Chicago is populated with the latest result set of the query. Complete refresh features. It's easy to implement because we just need to run the refresh mechanism dbms_mview.refresh procedure as we have seen in the demo section, and we can perform the complete refresh ideally for every materialized view. It can be costly based on the data involved. If data involved is very huge, so sometimes it becomes very costly to run the underlying select query of the materialized view. But the good thing about the complete refresh is that we don't need any additional structures for complete refresh. Fast refresh features. In case of fast refresh, the change data, or we may say the most recent DML operations which have occurred in the master table with the most recent refresh is identified, and the change data is only applied to the materialized view. Unlike complete refresh, the whole underlying select query is not run. Since less data is transferred and replaced as a result of fast refreshing, so we also call it as incremental refreshing. It is more efficient than a complete refresh when there have been few changes made to the master objects. In order to identify the rows of the master table which must be refreshed, the database uses a materialized view log at the master site to keep track of the updates. The materialized view log at the master site can log different information. However, all materialized views cannot be fast refreshed. there are certain restrictions with the materialized views as well. We cannot fast refresh the complex materialized views that I will be covering in the later slides. The figure demonstrates the fast refresh setup. We have master and materialized view site. The materialized view creation script is present in the coded box. Now, when initially the materialized view is created, it will have all the data corresponding to department number 10. Now, say for employee number 101, the salary has changed and new salary is 201. Now, with fast refresh, once an DML operation is performed on the master table, that is the EMP table, in present case, a trigger will be fired internally and the record will be applied to the materialized view log, that is mlog $_EMP table. Once the record is applied to the materialized view log, when we perform the fast refresh of the materialized view, instead of running the whole underlying select query of the materialized view, only the change record is taken from the materialized view log and applied to the actual materialized view. So the materialized view is in sync with the master object at the end of fast refresh. Force refresh. A force refresh operation tries to perform a fast refresh. Then, if that fails, it tries to perform a complete refresh instead. Fast refresh might fail because the structure used to identify the change rows at the master site were not created, or because of the subquery condition discussed later in this section is not met. Whenever you create a materialized view without specifying the refresh mechanism, force refreshed are used. This brings us to the second demonstration part. In this particular section, we will see different refresh types. We will try to create materialized view with different refresh mechanisms. So we will create a test user and grant the necessary privileges to the test user, and we will connect to the test user and try to create a master object, that is project in the present case. Alter it to have a primary key and insert the record 1 and P1 in this master table. Now the project table is created. We will commit the record and create a materialized view log with primary key option on the master table. The materialized view log is required for fast refreshing of the materialized view, as it will contain the changed records. All the information required for the changed records will be contained inside the materialized view log. We will create the materialized view with fast refresh option with name project _MV_FR. Here we go. So the materialized view is created. Insert a record in this particular materialized view and commit the record. Now, in order to see if the newly inserted record is present in the materialized view, in order to sync the data, we need to refresh the materialized view using dbms_mview.refresh procedure. So the procedure has run. Now let us see what kind of refresh has been performed. It is fast refresh because the materialized view has been created with the fast refresh option, and we have the materialized view log present on the master table to entertain the fast refresh. Now let us see if the records are present in the materialized view? Yes, the records are very much there. So we will again connect SSDBA and drop the user to have the latest, to create a new project table for other test. So we have created a user test. We are granting the necessary privileges to the user test, and we have also granted drop any materialized view to test. Now we will connect as user test and create the master table project, in this case with p number and bracket 2, alter it to have a primary key and insert a record in this table. So a row is created. Now we will create a materialized view with refresh complete option and see if the inserted record gets reflected in the materialized view after it has been manually refreshed. So here we go, we run the dbms mview.refresh procedure and see we have the last refresh type is complete refresh. If we select from the materialized view, we can see the latest data is present inside the materialized view. Again, we will connect SSDBA and drop the user test with cascade option, and again connect the user test. We will grant the necessary privileges to the user test and do the next round of testing. So we are granting the necessary privileges to the user test. Connect as user test and create a master table project with p number and p name. Alter it to have a primary key and insert a value 1 and p1 in this particular table, and we will commit it. We will create a materialized view log on the project table because that is very much required in order to work with the fast refresh option of the materialized view. A materialized view log is created, and we have created a materialized view with refresh force option. That means by default it will be performing fast refresh first if that is possible, and if that is not possible it will go for complete refresh. Now materialized view is created. We will insert a record 2 and p2 in this materialized view and run the dbms mview.refresh procedure and check out the last refresh type. We can see the last refresh type is fast refresh because the materialized view log is already present there and it satisfies all the conditions required to fast refresh the materialized view. So it has gone for fast refresh even if we have specified force refresh as option. So it is working as expected. So we will select from this particular materialized view and see the latest inserted records are present there. Now we will drop the materialized view log and see how force refresh behaves. We will insert one more record in this and run the dbms mview.refresh procedure. Now we have seen the last refresh type is complete because there is no log present on the master table, and we have specified force refresh as the refresh option. So since it's not able to do the fast refresh, it has gone for complete refresh. Now let's see the records in the materialized view. The latest inserted record 3 and p3 is present in the materialized view. Again we will do the cleanup of the user test, and then again we will create it and grant the necessary privileges to the user test and go with other round of testing. Now we will connect as test and create the project table. Once this is done, we will alter it to have a primary key and insert a record in this project table and commit it. Create materialized view log on the project table, and now we are going to create a materialized view with refresh fast on commit option. When we specify on commit option, the refresh is done, the refresh is triggered at the same time when we commit the record at the master site. So let us see what behavior can be seen from this test. Now we are inserting a record 2 and P2 in the project table and we commit it. Once we commit it, internally it will trigger the refresh of the materialized view, and we need not to manually perform refresh of the materialized view. If we select from user and views, we can see last refresh type is fast refresh. This is fast refresh, and we have not manually performed any refresh operation because the materialized view was created with option refresh fast on commit. So once we have committed the record, internally the refresh operation has run and refreshed the materialized view, and the latest data can be seen in the materialized view. This brings us to the end of demonstration second, and going back to the main slides. Triggering a refresh operation. As we have seen in the demo section, we can manually refresh the materialized view. However, we can schedule the materialized view as well. To refresh a materialized view individually, we can use dbms_mview.refresh procedure that we have covered in the demo section as well. However, we can specify the method to refresh the materialized view as well in this particular procedure. Say if a materialized view has been created with a fast refresh option, and the requirement sometimes is to refresh it as complete, we can specify in the method, we can specify complete refresh and it will go for complete refresh. If we have scheduled the refresh operation, we can simply run the job number in execute dbms_job.run job number, and refresh will be run for this particular job ID. We can schedule the refresh of materialized view during the creation of the materialized view itself. This can be done by specifying the start with and next clause during the creation of the materialized view. This is the pictorial representation of periodic refresh. Create materialized view, view name, refresh fast or complete or force, start with and next clause will schedule the refresh. Materialized view logs. Materialized view log is a table that has to be created manually by the user in case of fast refresh. It has to be created at the master site. When DML changes are made to the data in the master table, rows describing those changes are stored in the materialized view log. The materialized view log is then used to refresh the materialized views based on the master table. This is the increment or fast refreshing process. If the materialized view log does not exist, the materialized view query must be re-executed to refresh the materialized view. The process is called complete refreshing, which we have covered in the previous slides. Usually fast refreshing takes less time than complete refreshing. When we create a materialized view log on a table, master table, the database creates a table called mlog$_table name, which records the columns used to identify the changed rows in the master table. A materialized view log is located in the master database in the same schema as the master table. The syntax to create the materialized view log is create materialized view log on table name with primary key or row ID. Or we can just specify primary key or row ID or both of these clauses. Materialized view log features. We can have two types of materialized view logs, either primary key materialized view logs or row ID materialized view logs. If we don't specify any clause during the creation of the materialized view log, by default the log will be created as a primary key materialized view log, subjected to the condition that the master table has primary key constraint enabled. If the master table has no primary key enabled, we have to use the row ID materialized view log to uniquely identify the records that have been changed at the master site. Sometimes we do use filter and join columns in addition to the row ID and primary key of the materialized view log to uniquely identify the records to satisfy the fast refreshing. Materialized views which cannot fast refresh or complex materialized views. I will be covering complex materialized views in the forthcoming slides. This is the pictorial representation of the materialized view log. Create materialized view log on schema.table name with object ID, primary key or row ID on columns blah blah blah. We have two types of materialized views as well. One is primary key materialized view and other is row ID materialized view. By default, when a materialized view is created, it is a primary key materialized view, subjected to the condition that primary key constraints are enabled on the master objects or master tables. In the coded box, we have specified with primary key option. However, if we don't specify this option, by default as well, it will go for primary key materialized view. With primary key materialized view, the administrator can reorganize the master table at the master site without affecting fast refresh operations. Other kind of materialized view is row ID materialized view. If primary key is not present on the master object of the materialized view, then we have no option to uniquely identify the records at the master site. We can only uniquely identify the records with the help of row ID. So we need to specify with row ID clause during the creation of the materialized view. Now, if there is no primary key present on the master object of the materialized view and we don't specify any row ID, the statement the creation script will not go because it's not able to uniquely identify the records that are required for fast refreshing of the materialized view. Analyzing materialized view for fast refresh. We have a procedure dbms_mview.explainMView to determine if the materialized view can be fast refreshed or not. Once this procedure is run, it will populate the mv_capabilities_table with results, and we can query this particular table to determine if the materialized view can be fast refreshable or not. Steps to analyze materialized view. Truncate table schema name.mv_capabilities_table. We are truncating it so that it does not contain any prior information, and we can execute dbms_mview.explainMView schema name.materialized_view name. Or if the materialized view is already not created, but we are sure about the underlying select query of the materialized view that we are going to use for the creation of the materialized view, we can directly use this particular query in the dbms_mview.explainMView procedure and check out whether The materialized view can be refreshed fast or not if the materialized view is created with this particular select query. After executing the dbms mview.explain mview procedure, we can check the capability name possible and message text from mv_capabilities_table to determine if the materialized view can be fast refreshed or not. Complex materialized view. Fast refresh is not always possible, and a materialized view is called complex whenever the fast refresh is impossible. In such case, there is no way to pinpoint individually changed rows from such a query by means of materialized view log on the underlying table. For example, the queries that contain analytical functions like rank or clauses like all, not exists, having, model, connect by, etc. There is no way to uniquely identify the changed records at the master site. So these kind of queries are called complex queries, and the materialized views created on top of these queries are referred as complex materialized views. In order for fast refresh to be possible, a materialized view defining query must obey certain restrictions. That means it should not contain any of these clauses, which makes the materialized view complex. A materialized view that violates one or more of these restrictions is called as a complex materialized view. But the good thing here is, even if the materialized view is complex, we can still complete refresh the materialized view. That will always work for any kind of materialized view. Pre-built materialized views. At the segment level, the materialized view and the table are same. The biggest difference between a table and the materialized view is the inability to add or modify columns in the materialized view, which is quite simple to do with a table. In case of materialized view, if we want to modify the columns, we need to drop and recreate the materialized view. Otherwise, there is no option to add or modify the columns in a materialized view. But we can make the process a little easier by creating the materialized view on a pre-built table. If you look into the coded box, you can see we have created a table named MV1, and on top of the table MV1, we have created a materialized view with same name MV1. The table and the materialized view should have the same name. Once the table has been modified to suit you, just use on pre-built table clause to create the materialized view, and you are back in business in no time. The end user sees no difference except that materialized view on pre-built table eliminates the burden of standard drop and recreate of a materialized view and associated table. A materialized view on pre-built table can be used on tables of all sizes. However, it is most beneficial for materialized views which are huge in size, and drop and recreate may take days or hours. This brings us to the demonstration section. Here we will try to determine if we can query the various tables to determine if the materialized view can be fast refreshable or not. So here we go. We have created a user test, and we have granted the necessary privileges to user test. That is, create any materialized view, and we have also granted the drop privilege to the materialized view to clean up the setup. Now we will connect as user test and create a project table with p number and p name as 2 columns. Now the table is created. We will alter it to have a primary key, as we have discussed in the main slides. We need to have a primary key to uniquely identify the records or if the primary key is not present, we can use row ID materialized view and row ID logs. Now here in the example we are altering the table to add the primary key, and we are inserting a record 1 and P1 inside this table. Now we will commit the record and create materialized view log on project with primary key. Even if we don't specify the primary key option here, by default it will go for creation of primary key materialized view log, because the table has already primary key enabled. Now the materialized view log is created. Now we are creating a fast refreshable materialized view, that is project mv_fr refresh fast on demand as select star from project. The materialized view is created. We will insert a record 2 and P2 in the master table and commit it. Now the commit is complete, and we will run utlxmv.sql script that will create the tables which are required to determine if this is fast refreshable or not. Now execute dbms_mview.explain_mview, and then we will give the materialized view name in single quotes. Once this is done, we can select the capability name and possible related text from capability table, and here are the results. Refresh fast, yes. Refresh fast after insert, yes. Refresh fast after one tab DML, yes. Refresh fast after any DML, yes. Refresh fast PCT, and that is no. PCT is not possible of any of the detailed table in the materialized view. Execute dbms explain mview. Here we will provide the underlying select query. When we run this, we can see the similar results. So in dbms mview.explain mview procedure, we can either directly provide the materialized view name, or else we can provide the underlying select query, and if we can get the results about the fast refresh of the materialized view, if that is possible or not. So in today's session, we have covered the basic architecture of the materialized views and objects involved in the materialized view, various refresh types that can be used for the materialized views, materialized view types, materialized view log types, capabilities of the materialized view, and how we can determine if the materialized view can be fast refreshed or not, and creation of the materialized view for pre-built table option. So this brings us to end of this section.
So thank you, Shibata. This is the end of our presentation, and we will now come to our Q&A session. For those of you who are listening on the telephone, you can now ask questions on the phone. The others can ask questions on the Q&A panel located on the right side of your screen. We will read the question aloud, and Shibata can answer it. All unanswered questions from today we will transfer to community as already mentioned, and a specialist will answer the question. Now, operator, can you please let us know how to ask questions on the phone?
At this time, I would like to remind everyone, in order to ask a question, press star and the number 1 on your telephone keypad. We'll pause for just a moment to compile the Q&A roster. There are no questions at this time. Go ahead.
Okay, thank you. So we will come to questions from our Q&A panel. The first one, when will the create materialized view use a scheduler instead of DBMS job to create a refresh job?
Can you go again?
When will the create materialized view use the scheduler instead of DBMS job to create a refresh job?
That is up to the user. We have two ways of scheduling the refresh mechanism. One is at the creation time itself, we can use the next clause and schedule the refresh in future, or the normal database job using the scheduler job, we can submit the job to refresh the materialized view. So it's up to the user. There is no restriction on this. This depends entirely on the user.
Okay, I hope this answers the question. Coming to our next question, is it necessary to create a materialized view log? Shibata, did you get this question?
Yeah. Can you repeat it again, because it does not seem a complete one.
Is it necessary to create a materialized view log?
Yeah, materialized view log is necessary for fast refresh of the materialized view. If we have created the materialized view with fast refresh option, we need to have the log at the master site for the master table. Otherwise, if we refresh the materialized view, it will error out saying that the materialized view log does not exist. So the only option in that case is go for complete refresh.
Okay. Can we do fast refresh on particular partitions of the master table?
Fast refresh is done on the materialized view. So that means we during the materialized view creation, we have an underlying select query. And the materialized view will contain the results or the columns that are reflected in the underlying select query of the materialized view. It's not, the refresh mechanism is not for refreshing the master table, it's for refreshing the materialized view in order to keep it in sync with the master table. So it's the refresh mechanism is meant for materialized view, it's not meant for the master table.
Okay, now coming to the next one. Is it possible with a materialized view log to track changes to a specific column of the master table instead of the full rows of the table?
The materialized view log automatically determines the changes that has been done at the master table. The materialized view log, if we describe the materialized view log, if we have created as a row ID materialized view log, it has some specific columns like m_row $, snap time $, DML type $, old new $, changed vector $. These columns are used to uniquely identify the records which have changed as the master object. So user has no control on the materialized view log. User just needs to create the materialized view log, and it will get created with the desired columns that will track the changes that DML operations or the changes that has been done at the master side. It will automatically record those changes, and once we perform the fast refresh, the changes will be applied to the materialized view side. So the user has no intervention in this. It will be automatically taken care of once it has been created.
So I believe the next question is very close related to this. Do you need to manage or purge the materialized view log?
Purge again is automatically done
Yeah.
for the materialized view log. Once the records corresponding to a particular materialized view has been applied to the materialized view, the corresponding record will be purged from the materialized view log, but we do not do that manually. It is automatically taken care of. We do that only if there is some problem with the materialized view. Say, for example, if the materialized view has been dropped and the master site is not aware of the drop of the materialized view because of any network issues, etc., and the record has not got purged from the materialized view log. In those cases only, we do a manual purge. Otherwise, it is automatically taken care of, and we don't suggest customers to go ahead with the purge unless they verify the issue, and if they are not very sure with the issue, they can always contact the Oracle support for help and do the purge only once they are guided to do that. Otherwise, we are not supposed to do any operations on the materialized view log.
Okay. So let's have a look to the phone again. Operator, do we have questions from customers now?
Again, if you would like to ask a question, that's star, then the number 1 on your telephone keypad. And your first question comes from the line of Vino Gadar.
Hi, this is Venu Gadar. I have a question. Will there be any impact on the database, on the performance related in using materialized views?
See, in the slides also I have covered that there is always a cost associated with every product, and since for materialized views also we use the refresh mechanism, so it will be requiring some resources, as well as we have the objects associated with the materialized views, and since materialized view is physical in nature, so we need the disk space as well for this. For the materialized view setup, we need the I/O operations, so we need additional resources. So obviously, it is going to take the resources. It will have some performance issues as well if it is not tuned properly and the materialized view setup is not done correctly. Otherwise, otherwise it should go fine if we have the underlying select query of the materialized view properly tuned and we are following the guidelines.
Thank you.
You're welcome.
And your next question comes from the line of Jeff Key.
Yeah, my question is that I understand that if the master table from different databases, so like materials view actually based on multiple tables, you have to create multiple logs for that, right? So my question is that if the materials view only affects certain columns, but not all the columns, the material view log will capture all the other column changes as well? Because it has a burden on that. It's a performance issue as well.
It will not log all the columns. That is why we are creating the materialized view log as primary key materialized view log or row ID materialized view log. So we are tracking the changes with the primary key column or with the row ID in addition to some of the other columns which get automatically created with the creation of the materialized view log. If we don't have any primary key on the materialized view log on the master tables of the materialized view, and we don't create the materialized view log with row ID option, we have no means to uniquely identify the records that have changed at the master site. So the primary key.
No, my question actually is that the primary key is that in place. Of course, you can utilize it to identify uniquely. My question is actually is that, like you have 10 columns, only 5 columns used for the materialized view. But I don't change that. But according to primary key, it's still going to capture in the log, right? Because we're adding more performance to the material view. Is that the case, or is that situation?
Yeah, even if primary key is used to uniquely identify the record. But if the materialized view underlying query is complex and the materialized view log is we can check if the materialized view is fast refreshable or not from the MV_capabilities table. And if we see that it's not fast refreshable, probably the reason for this not being the fast refreshable materialized view will also get reflected from that result. And once we look into the result, we may have an idea of why the materialized view log cannot be fast refreshed. And there is one more procedure, that is tune materialized view. We can run that procedure, and that gives us some of the recommendations. Maybe sometime it asked us to create, the log with some of the additional columns that will help in unique identification of the records that has been changed at the master site.
Okay, thanks.
You're welcome.
And the next question comes from the line of Mary Paulson.
Hey, can we use ListAg as fast refreshable, and if not, is there a plan to do that?
Sorry, can you repeat your question? Explain in more detail what exactly is your question?
We want to use ListAg as part of our select statement for the MView. And we found that we can't make it fast refreshable, and wondered if that's true, if we're just doing something wrong, or if if it's going to be supported at some point.
You can check the MView_capabilities_ table, and if in that particular table you determine that if it states that the materialized view can be fast refreshable, you can go ahead with the actual creation of the materialized view. We have two options to check the results from the MV capabilities table. One is, if the materialized view is already created, we can specify the materialized view name itself, or else if we are aware of the query that we will be using in the creation script of the materialized view, we can put directly that particular query and determine if we'll go ahead with that particular query, will the materialized view will be fast refreshable or not. And if it is not fast refreshable, it will state the reason of this being not fast refreshable. And if you want to go further, you can use dbms_mview.tune MView procedure and see if it provides you any recommendations to tune the materialized view to refresh it fast.
Okay, thank you.
Welcome.
Your next question comes from the line of Mark Andre.
Hello. I've never used Materialized View, and my question is very basic. In what type of situation do you recommend to use Materialized View?
Well, Materialized View can be used as we have covered in the very basic slides. It can be used for expensive queries. If a query is involving joins or aggregations and complex joins, complex aggregations, and if we run that particular query directly on the master objects every time, say you have a query which is very expensive, and you have to run that particular query 10 times a day. So 10 times you are running the query on the master objects, 10 times the query passing is done, the IOs are involved, resources are involved. So instead of that, if the pre-computing data is already present in the materialized view, you need not to go to the master objects always, because the result set is present in the materialized view. You can directly run the query and the results will be obtained from the materialized view itself. So that leads to better performance.
Without having to rerun the complex query?
Sorry?
Without having to rerun the complex query. Is that correct?
You need to run the query, because it is it's transparent to the end user. If you have query rewrite enabled in your system, in your materialized view setup, automatically the optimizer will determine if the result set is present in the materialized view. It will fetch the results from the materialized view, and if the result set is not present in the materialized view, it will run the query on the master tables.
Okay, thank you.
The end user is not aware from where the data is fetched, but it is optimizer's job to determine whether it should direct the query to the materialized view or it should take the results from the master objects.
Thank you. Thank you very much.
Welcome.
And there are no further questions at this time. Go ahead.
Okay, thank you. So we will continue with our questions from Q&A panel. Is it possible and how to add columns into a materialized view?
We cannot modify the columns in the materialized view. We need to drop and recreate the materialized view. However, we can use pre-built option for the materialized view. That means we can create a table with the desired structure, and once the table is created and populated with data, we can create a materialized view on top of the pre-built table. So the results are present in the table. The structure is also equivalent to the materialized view, and we are back into business in less time.
Okay, our next question. When is a table purged for fast refresh?
Yeah, I believe I have covered it in the second question, but still I will cover it once again. Once the record has been applied to the materialized view, and the materialized view internally gets the confirmation that the record has been applied to the materialized view, it will purge the record from the materialized view log.
Okay. So next question regarding performance and optimizer. Will the optimizer automatically choose materialized views?
Yeah, it is the operation when the end user runs the query. The whole thing is transparent to the end user. He needs not to do any modifications to the query. If query rewrite is enabled, the optimizer will determine if the results are present in the materialized view. The results will be fetched from the materialized view. Otherwise, the query will be directed to the master objects.
Okay. Will the materialized view become invalid when the master table is dropped?
When the master table is dropped, we don't have we don't have the master table, so materialized view does not come in picture. We cannot do anything with the materialized view. So it will be invalid, and it will be invalid also when we perform any DML operation on the master table, because invalid status just tells us that it is not in sync with the master table. And if we don't have the master table to get the records from, to get the data from, there is no meaning of the materialized view.
Okay.
But if
go ahead.
But if we don't need the latest data from the master table, they can use the materialized view as well. So it depends upon the business requirement. Some customers do create the materialized view only once, and then they use that materialized view for their own business requirements, and they don't refresh it at all. So in that case, if they have such kind of requirement that the materialized view has to be created only once and it has not to be refreshed, in that case, even if the master is gone, we are not bothered about that, because we don't need the latest data from the master side. Refresh mechanism is used only to keep the materialized view in sync with the master objects.
Okay. So Shibata, the next one might be a question about best practice. So the question is, would it be advisable to run and explain against a SQL query first before creating a materialized view to see what capabilities such a materialized view will have?
Yeah, you can always go ahead with, if your requirement is to fast refresh the materialized view, you can always go ahead and run the query first to predetermine if the materialized view can be fast refreshed or not, if the same query is used for the creation of the materialized view.
Okay, and What about CLOB and BLOB? Are these objects fully supported for fast or complete refresh, or just through database link?
Well, again, we do have restrictions with CLOBs and BLOBs as well, but at this point of time, I cannot comment on this because there are various scenarios wherein this can be or cannot be. So better to use the MV capabilities table to predetermine if the query can be fast refreshed or not.
Okay, thanks, Shiwata. Let's have a last look to the phone operator. Are there questions at this time?
If you'd like to ask a question, that's star, then the number 1 on your telephone keypad. There are no questions at this time. Go ahead.
Okay, thank you. So this will conclude our Q&A for today. And I want to end our webcast with short introduction, instructions, how to get the recording for this session, and how to find the presentation. First of all, our generic advisor webcast note, this is a note number 740966.1. That's always the starting point for any download of recording or material or whatever. From this note, you can get recordings and material for any product. In our case, the product is Oracle Database. So select Oracle Database from the drop-down menu, and you will come to the next note. This is the database advisor webcast note, and in Archive 2015, you will find all the webcasts that we did so far. And here in this list, search your webcast. For instance, this one is the session you want, and here at the end, you have the recording link and the PDF link. With these links, you can download the recording and the PDF for today's session. Next, some links about the community. This will be in your material, and if you want, you can follow these links to get more information about our proactive work. And last but not least, a short hint about our communities. So communities are accessible through My Oracle support, step by step, or if you know the community, you can also use the link communities.oracle.com, which is the second option. So on My Oracle support, you have the community button, and this will bring you to communities as well. The relevant community for today's session, this is Oracle Database, data warehousing. So in this community, you will find this PDF material and also the discussion thread for today's session. As I mentioned before, all unanswered questions from Q&A panel will be transferred to this place, and the expert will answer these questions in the next few days. And also, if you have further questions after today's session, you can put your questions here, and someone will answer this. The material can be found under Contents and Documents. This will bring us to the end of today's session. We hope you found this webcast valuable and looking forward having you joining us again. Please enjoy the remainder of your day.
This does conclude today's conference call. You may now disconnect. Speakers, please hold for post-conference.